Hello and welcome to this video on expectation and variance of the probability distribution. I expect this to be a short video. It's not a concept that I want to go into much depth theoretically, but I want to show it in practice. So just as a comment, if you imagine an experiment that is done repeatedly, and here talking about a random experiment done repeatedly, you can register the occurrences and you will be getting a frequency distribution. Thus, you're connecting to the previous part of the chapter that had to do with statistics. And you can find for this distribution a mean. That mean is what we would call, in the context of a probability distribution, its expectation or the expected value. We can think of the expectation as to being a long-term average. Let's say if you produce this many times, well, what is it that you're expecting to get? And it's a very interesting concept that we can use in numerous exercises. It's very useful. There are some really interesting applications for this that I'm not going to be presenting now because I want to emphasize mainly on what the AS and A levels may ask you. But I highly recommend that if you're interested in this, you look up it. So we have this expectation, and we're going to be using for now E of X. This is one of the accepted notations. You will see that when we get into depth with the binomial and the geometric distributions, we're going to be including other notations for this as well. But this is one of the most general ones that we use. And then we're also going to include the variance of a standard and standard deviation of a discrete random variable. I want you to remember that the variance of a random discrete variable is the sum of the squares multiplied times in frequency, in case we're given with in a frequency table, divided over the sum of the frequencies and subtracting the mean squared. Well, we're going to be using the very same concept, but where the frequency is going to be the probability of that value, and the sum of the probabilities is 1. Remember that we talked about that from the previous video, so we don't need to divide over 1. And then the mean is going to be our expectation. So this is how the variance is going to work. As usual, we're going to define as well the standard deviation to be the square root of the variance, just to go back to the unit of the problem. So we have these 3 elements that we can use, and thus we can get into work and find how this would work. We're going to see in this example how we can find expectation and variance. So first, how does this work? Well, the expectation is found as the mean of the values by using that the probability is their frequency. So, for example, we would be saying that the value for x, that is 0, we're going to be multiplying it times its probability, times 1 over 12. I write that down now. Clearly, you don't need to write it because it's going to give you 0. But just for you to understand the idea of what we are doing, we are taking the value and we're multiplying it times its probability. Then we're going to add the second value, that is 5, multiplied times 3 over 12, plus 15 times 5 over 12, and then plus 20 times 3 over 12. Here we don't know what these values means. It's just data that is given to us. So we're just going to be making the operations, and this is going to give us a value of 12.5. This is the expected value for this distribution. This is a very theoretical exercise where, as I told you, there's no actual meaning for these numbers. It's just the example, but you can see that it's quite straightforward. There's x times the probability plus x times the probability plus x times the probability, and so on, and you plug it all in and you do the operations. It's just that. What happens with the variance? Well, for the variance, we will be doing almost the same thing. It's just that we're going to be taking the square of the values on x, and then we have to subtract the mean squared. So this would be the value for x0 squared times 1/12 plus the value of 5 squared times 3/12 plus 15 squared times 5/12 plus 20 squared times 3/12, and then we're going to subtract 12.5 squared. We plug all that in, we do the calculations, and we get a beautiful 43.75. And that would be the value for the variance of this random variable. And then finally, the standard deviation for x is going to be just equal to the square root of 43.75. That is equal to 6.61. Here, I again want to make a comment that is very important. I have done this comment before, I have made it before, and I will be doing it again as long as I need to make it. Do not round intermediate values. Okay, as I told you, you are clearly allowed to omit some things. For example, here you can go and say, well, yes, I'm not going to write you. That's fine. You can omit that. As well as I'm not dividing over 1. It's not necessary to divide over 1. But when you give your final answer, for example, this solution, it may be rounded, and it's fine because it's a final answer. But if I had to use this in order to find this, I need to use the exact value. Because if I'm not using exact value here, then I'm going to be introducing an error here. And here is when I cannot have a previous error. So in case you're working with your calculator, and I hope that you're doing this, you may be doing this by hand, and I applaud you for that. But in case you're working with your calculator, you can write this number down, but don't discard it yet. Just use the answer button, place square root of the answer, and you will be getting that. And that's the safest way for you to deal with all of these problems with roundings and everything. So this is going to be the end of this video. I believe that I made it as short but also as complete as possible. As usual, you can find more things about this in my website. If you do have anything you may want to ask, feel free to use the comment section below. And I hope to see you in our following videos where we go over these two special distributions that are the binomial and the geometric that we will be dealing with there, and we will see how they can help us solve even some real life problems. I will see if we can mix them up here. If not, you will find them in the website as well. So as usual, thank you for watching.